Good morning students. This is our next video lecture of unit Electrochemistry. In the last video lecture we have discussed about the Nernst equation. In the Nernst equation we have discussed that how you can calculate electrode potential of a cell when its concentration is different from 1 molar and its temperature is also different from 298 Kelvin. Means standard conditions are not present in the cell. Then how you can calculate EMF of the cell. So now we are going to discuss about the Nernst equation in case of Daniell cell. First we write the equation of Daniell cell. Zinc plus copper ion gives us zinc ion and copper. Zinc undergo oxidation. So oxidation occur at the anode. Zinc convert into Zn plus 2. Copper ion will reduce into copper. So according to Nernst equation, EMF of the cell can be written as E naught of the cell. E naught means standard EMF, RT, R gas constant, T temperature, N number of electron which are involved in the chemical reaction. In the Daniell cell, number of electron N is equal to 2 because 2 electrons are transferred. Now F is Faraday constant and value of the F is 96500 Coulomb. Natural logarithm of ions. Now we dissociate this Daniell cell into two half cells, means cathodic and anodic. At cathode reduction will take place, so copper ion convert into copper, so it will occur as Cu2 plus 2 positive this. According to Nernst equation, the half cell reaction, we can write the EMF of this half cell reaction. So EMF of copper 2 plus 2 copper, E naught minus RT over 2 electron are involved, so it is given as this. Concentration of these ion are taken as 1. We have discussed about it. At anode we take reduction potential, but at anode there is oxidation occur, so we write this equation in the form of the reduction. So here EMF of the Zn plus 2 to zinc, it gives E naught of this minus RT over 2F ln of this. We can write it both. This is our reduction half cell and this is our oxidation half cell, means the electrode at which oxidation and the electrode at which oxidation occur. But we convert this oxidation half cell into reduction by the reversing the reaction. So we can write these two equations. Now combine these two equations, then we can calculate the EMF of the cell. EMF of the cell generally we calculate by subtracting EMF, yes, standard EMF at the cathode minus EMF at the anode. Cathode is present at the right hand side, RRCP, and anode is present on the left hand side when we represent a electrochemical cell. So we subtract EMF at the cathode minus EMF at the anode. At the cathode EMF is equation first and at anode equation number 2. So we subtract both these equations. So here we write EMF of the cell, EMF of the copper and EMF of the zinc ion. Both are subtracted. Then we can write this equation like as. From both these equations, E naught of the copper and E naught of the zinc are given here minus RT over 2F of copper ion written here, and this minus and minus convert into plus RT over 2F of this. Now we can use EMF of the cell E naught. This is our standard EMF. It is written as E naught of the cell minus, this sign is minus RT over 2F ln. Copper ion are present on the denominator side, and when this comes in the numerator, negative sign occur, so negative is here, so it is in the numerator. So we can write the Nernst equations for the Daniell cell is like this. EMF of the cell is equal to E naught, standard EMF of the cell, minus RT over 2F ln of. Ln is the natural logarithm. It can be converted into log 10. It is multiplied by 2.303. And putting the value of R 8.314 joule per mole Kelvin, temperature 298 Kelvin, and Faraday constant value is 96500. So the EMF of the cell for 10L cell is out this. So we can write Nernst equation for any cell or any electrochemical cell by using this relation. Now we consider a general equation and try to write the Nernst equation for this general equation. Let us consider a general equation. This is small a plus b. If n electrons are involved in this reaction, this is C plus D and D. This is the electrochemical cell. Then we have to write the EMF for this cell. Then it will be E naught of the cell minus 0.0591 over n, because n electrons are involved, into log of concentration of product side. Product side is C. Stoichiometric coefficient is small c, and it is D. Stoichiometric coefficient is this, and we can write it here A. Stoichiometric coefficient is A, and in case of B it is B. So we can calculate the EMF of the cell for a general equation which is given in the questions. Okay students, let's start some numericals based on the Nernst equation. So our first question is, it is important question, at what pH of HCl solution given as HCl will give hydrogen gas, means it gives hydrogen, means H2 gas. Electrode, show an electrode potential of this. Electrode potential value given here is EMF given here is minus 0.118 volt. Hydrogen gas is at the standard condition 298 Kelvin temperature and pressure is 1 atm. When HCl break down, it gives H plus and Cl. So the hydrogen undergo reduction. So we can say the electrode reaction is it will takes place according as H plus ion, which is produced from the HCl. It accepts one electron. Hydrogen gas is evolved, so it converts into H2. Reaction will occur as like this. So we can write Nernst equation for these cells. So EMF for conversion of H plus into H2 will be equal to E naught standard for H plus to H2 minus 0.0591 over n. Value of n here is 1. So it is 1 log of concentration of 1 over H plus. We can write it like this. Standard EMF for the hydrogen taken as 0. So we can say that EMF of H plus to H2 will be equal to minus 0.0591 log of H plus ion concentration. If it is in the minus, we can take it in the positive direction. If it denominator to numerator, it will positive. And EMF we have given, this is equal to minus. So it is minus of 0.118 is equal to 0.0591 log of H plus ion. This minus is here, so it is 0. We can write it here minus log of H plus. Minus log of H plus, why we write it? Because minus log of the H plus is equal to the pH, is equal to, this minus is here, so it is 0.118 by 0.0591, and minus log of this is equal to pH. So we can calculate it by dividing this, and it comes out to be approximately equal to 2. So we can calculate pH, it is equal to 2, because minus log of H plus ion concentration is equal to pH. Simply first HCl break down into H plus and Cl minus. H plus undergo reduction, it gives the hydrogen gas, so it is H plus plus 1 electron accept, undergo reduction, it gives half molecules of hydrogen gas. Then we can write Nernst equation for it. Standard EMF for hydrogen is equal to 0. It can be converted into pH, and pH comes out to be 2. Next question. Next question is represent the cell in the following reaction taking place. We have given a cell, reaction is given here. We have to represent it in the form of the cell. सेल की फॉर्म में इसको हमें क्या है रिप्रेजेंट करना है. सो मैग्नीशियम अंडरगो, it will undergo oxidation. It is convert from magnesium to magnesium plus ion, and silver undergo reduction. According to Lone and RRCP, Lone means left side oxidation act as a anode and it is positive. So element which undergo oxidation is written on the left hand side. So it will be written as, the cell can be represented as, cell represented as, it can be written as magnesium convert into magnesium plus 2 with their concentration 0.130 molar. Now salt bridge is represented, and next is silver ion Ag plus with concentration 0.001 molar into silver. This is solid. So we can represent the cell in the form of this Mg2 plus Ag plus 2 Ag. Now second part asked in this question, calculate EMF of the cell. We have to calculate EMF for this cell if E naught is given. So write Nernst equation for this. So EMF of the cell is equal to E naught of the cell minus 0.0591 over N. For this reaction N is equal to 2. 2 electrons are involved, so it is 2 log of concentration of product side concentration. So it can be written as Mg 2 plus ion concentration by Ag plus, and it undergo square because stoichiometric coefficient occur in the power of this. Stoichiometric coefficient is 2, so it in power. And the solid state solutions have concentration equal to, a metal have concentration, this is equal to 1. So we can calculate it. EMF of the cell is equal to E naught given in the reaction, it is 3.17 minus 0.0591 by 2 log of concentration of magnesium ion given here 0.130, and concentration of silver ion is 0.001 to the square. When we solve it, then EMF of the cell come out to be 2.96 volt. This is our answer. So if we have to calculate, we have to represent any cells, then we apply Lone and RCCP. The metal which undergo oxidation is written on the left hand side, and the metal which metal ion which undergo reduction is written on the right hand side, which act as a cathode, and left hand side act as a anode. So we can represent the cell. And next point is EMF of the cell can be calculated simply by using the Nernst equation. Okay students, now we can calculate equilibrium constant from the Nernst equation. How you will find out equilibrium constant? Equilibrium constant occur at when reaction is in equilibrium condition, means rate of forward reactions and backward reactions will occur at the similar rate. So it is a stage when electrode potential, in electrochemistry, when electrode potential of two electrode becomes equal. Electrode potential जैसे oxidation half cell and reduction half cells, their potentials becomes equal. Then current stop flowing in the circuit, and EMF of the cell is a 0. At this condition EMF come out to be 0. Why EMF come out to be 0? Because it is equal, both electrode potentials are equal. This indicates that equilibrium has been attained. At this stage equilibrium has occurred. So we consider an example for this. Zinc plus copper ion gives us zinc ion plus copper. So we write EMF of the cell is equal to 0. So we can write 0 is equal to E naught of the cell in the standard state minus 0.0591 over N. Value of N here is 2. Log concentration of ions of product by concentration of ion of reactant. At equilibrium, we know that ratio of the concentration of product by concentration of reactant will be equal to equilibrium constant. So we can write E naught cell हम इधर ले आएंगे, so it is E naught of the cell is equal to 0.0591 over N. This equal to Kc. So we can write here we can calculate equilibrium constant from this equation. E naught of the cell will be equal to 0.0591 over N log of Kc. Let's try one question based on this. Calculate the equilibrium constant. Calculate the equilibrium constant for the reaction. We have given a reaction copper plus silver gives us this. Same reaction given here. Given that E naught of this, first of all, represent this cell in the form of cell can be represented it as copper undergo oxidation. So it is written as copper plus 2 concentration. This is aqueous. Salt bridge is applied. And silver undergo reduction. So it can be written as silver into silver ion. It can be represented as silver ion aqueous into silver. This is our representation of the cell. This is cathode on the right hand side, anode on the left hand side. So we can calculate E naught. So E naught of the cell will be equal to E cathode minus EMF at the anode. At the cathode, ion occur is silver, and at the anode, ion is this. So EMF for the cathode given is here copper ion, cathode पर silver ion. So silver ion it is 0.80 minus. At the anode it is 0.34 volt. So we can calculate E naught of the cell. So E naught of the cell come out to be it is equal to 0.46 volt, and it is equal to this 0.0591 over N. What is the value of N for this reaction is 2. We can calculate log of Kc. So our Kc come out to be equal to 3.6 into 10 to the power 15. So we can calculate equilibrium constant by using this relation, equilibrium constant from the Nernst equation, or EMF and equilibrium constant relation. So next topic is concentration cells. What are concentration cells? Let's start. When two electrodes are of same material, two electrodes which are made up of same material means zinc, copper, iron, any two electrodes which are made up of same material, but concentration of the electrolyte means solution in which they are dipped is of different, means concentration is different, but they are made up of same material are called as the concentration cell. Example, for the zinc, we take zinc and zinc ions. So in first case zinc undergo oxidation and here zinc ion undergo reduction, but concentration is different. Concentration here zinc ion is C1, in this case the concentration is C2. Then EMF of the concentration cell at 298 Kelvin, we can calculate it like here. Simply apply EMF of cell 0.0591 over N log C2 by C1. C2 is concentration at the cathode by C1 at concentration of the anodic ion concentration. EMF of the cell come out to be positive if concentration of these ion C2 is greater than C1. Oxidation and reduction occurs at which electrode? कौन से electrode पर oxidation होगा, कौन से पर reduction? So because both are made up of same material, so oxidation occur with lower concentration. The ions which have lower concentration at which oxidation occur and it acts as a anode, and the reduction occur at that electrode which is higher in concentration, या ionic concentration is high. Let's take in the question. Calculate the EMF of following concentration cell at 298 Kelvin. This is given concentration we have given, so simply put up in this equation we can calculate EMF of the cell will be equal to 0.0591 over n. Value of n for this equation is 2. So it is 2 log of C2. C2 is 0.5 and C1 is 0.05. So we can calculate. So it comes out to be, it convert into 10 and log 10 is 1. It cancel with the 10, log 10 is 1, so it cancel by 2. So the EMF of the cell come out to be 0.0295. Approximately this is the EMF of the concentration cell which is given in the question. Okay students, we will continue our unit in the next video lecture. You have to try to solve questions based on the Nernst equation because it is very important topic for the exam point of view. Thank you.